Hello, I'm David D. Hilster. I am a critical thinker, dissident scientist, and I'm here to tell you the truth about science, something your university professors won't tell you, the mass media won't tell you, and certainly those science evangelists won't tell you. What am I here today talking about? Frame's derivation of autodynamics. What's that? Well, let's go up a step and say, I am here to show you a real, live proof of where special relativity goes wrong. And this is from Dr. Carezani, who is an Argentinian physicist. He's got a PhD in physics. He found this when he was from 20 to 24 years old, pretty young, about the same time Einstein invented this marvelous unicorn world of relativity. And he got there not by asking even a question about relativity, but asking a question about kinematics, that is, kinetic energy. And kinetic energy is when something hits something else. Well, in radioactivity and radioactive elements, you have stuff coming out, particles coming out without any provocation. There's nothing hitting it. So he asked the simple question to his professor, why are we applying, in this case, the relativistic or Einsteinian equations for kinetic energy to radioactive or decay cases? That is stupid, and actually it is. And then he went on to look into this and he found something even larger. And what did he find? He found out that there are superfluous frames in special relativity. To put it in layman's terms, he found out there's only one three-dimensional coordinate in the universe, and all we can do is move around the origin. That's my interpretation of having studied his work for many, many years, a couple of decades. That's what he has discovered. Now we're going to go through and show you where. Now, this has mathematics in it. It has calculus, in this case, derivatives. And so if you don't know that, I can't help you there, but I can show you and point to you what's the problem. What's going to happen here, we're going to show you, Carezani says, and they claim, the Lorenz equations. What are the Lorenz equations? They are equations that get you from one frame here to another frame here. And if you're moving like you're on a train and there's light and all that stuff, this guy Lorenz, he came up with a set of equations that will make your translations from one frame to another. So he has those transformational equations, very, very, very famous. And Einstein says, with my tenets and my assumptions of the world, I can generate those Lorenz equations myself. And Carezani says, okay, let's see what happens and how that can be done. So he went through that and he found, lo and behold, that in fact that was not possible. And in fact, when doing so, he found a problem with special relativity, and that is we can't use more than one frame. Well, let's get to it. This you have a link below on this. You can see the link here. It's discussing here, and we're going to look at the first thing, which is very simple. This is, he says right here, this is on the web page for autodynamics. Below is a universal system of frames for relative movement. So you have this point P, it's got its frame, call it F, and F prime is another frame, and in this other frame, F prime, this point P is moving with the speed respect v. So this velocity, this point, is traveling at v. This x prime, this change in prime, we're going to look at all these equations. So there's these equations. So you have frame 1 and frame 2, F and F prime. Okay? And so we want to find the first velocity, v prime. All right, so we're going to go down here, and these are the famous Lorenz equations. Let's see if I can make these bigger here. I'm going to click on this, see if we can do that. Oh, there they go. They are, in fact, bigger. You can see here, x prime is equal to x. Now, if there was nothing happening, you would just have x prime equal to x. That is, if the point P was right here, they'd be the same. So it's not. There's a speed, and it's traveling. So you have x plus the speed of this point, and it's traveling over some time, is equal to x prime. But Lorenz says, oh, you believe in relativity, then this beta squared, which is equal to v over c, don't worry, that's just a common thing. There's also, I think, Another one where you can have 1 over that. It doesn't matter how you do it. In this case, beta, 1 minus beta, that is 1 minus v squared over c squared. Now you can see if you have v and c the same, you'll get 1 minus 1 in the denominator, and explosion in math. You can't have that because you can't divide by 0. So that's the magic, of course, and the problem you have with special relativity. Here you have time t, same thing, t would be t, but no, you have it times the velocity over x times c squared. Again, not important. I can't go through Lorenz equations and tell you how to figure out. But this is to tell you how time will change and how x, in this case, contraction, this would be like length contraction, this would be time dilation. These are the equations of what we start with the Lorenz equations, okay? So we come down here and we're going to figure out the velocity according to special relativity. That's SR. The Lorentz, I'm going to keep it at this larger font. Maybe this is better. The Lorenz equations in differential form will take that same thing as the change of x prime over the change of t, the change of x over change of time minus v, same bottom. Here you have dt prime over dt. Again, this is differential equations. You have to take my word. You see there's a difference in the sign. Doesn't matter. I asked Carezani himself about that. It doesn't matter what direction it doesn't matter what the direction. We're looking at speed. We don't care what direction you're going, so it can be negative or positive. In order to find the velocity, we need to divide dx prime over dx by dt prime over dt. I am not going to go into this. You can sort of see some of this. You can see if you have dx over dt, you divide it by this, you cancel them out, you get dx over prime over dt. You flip this, you can see that you have dx, dt's cancel out. Okay, you get dx equals v prime. So what are we calculating? We're calculating v prime up in this. We have the v, and now we're going to calculate a v prime, which is dx, these equations here. Now what happens is you see that square root goes away, but again, I don't have time to go through the calculus with you. What's most important is for us to take a look at a couple things. He says this equation obtained by working two frames in relative motion with point P at rest and frame F above it. Yet equation 3 has 3 velocities, v prime, vx, and v. Here you have v and vx. They're different. Now, wait a minute. It's supposed to be the same. What it says, what is remarkable is that the velocity vx, right here, this vx, appears spontaneously through a mathematical operation of the derivative from the coordinate x in equation 1. There it is, equation 1. The derivative of dx over dt in equation 2, there it is. This innocent operation has no physical meaning. Again, I'm not going to be able to explain all this and all the math. Maybe someday we can go and put it all down. But most important thing is that we have what he's saying is there's no physical meaning when you take this derivative. Why? Because we're trying to take special relativity and generate the Lorenz equations from it. But we have a problem. We get spontaneous velocities that appear that have no physical explanation. Where on that? Where is this? Where on this diagram is it? It's not there. So what happens? We have that problem. There's no energy to move point P with respect to F coordinate system, because P is in the F coordinate system. It's at rest. Now we can get to the second part of the problem. And this you don't need to be a mathematician to know this. Putting P in its own frame does absolutely nothing. You don't need that. Throw away F. Just use F prime. That's what Carezani is saying. You can even get 3 of them. They have them with 3. And then you have all the calculations. All these things that you start doing calculus on. All the differentials that you do. what happens? They all make and appear mathematical operations during this process, which has no physical meaning. Oh, that's okay because we're getting to the end. No, it's not. It's physics. It has to mean something. Let's go further down. Keep reading here. This is the reason why the SR special relativity sum velocity equation fails to maintain momentum and energy conservation when the equation is applied to a dynamical physical phenomenon observed by observers in two relative frames in motion. Okay? Now we're going to look at force. Force, we have force equals m times a. A is what? The square of velocity. Velocity in differential form is dx over dt. That's why it's squared. Frame F force is the mass, the same mass, initial mass, except it's d squared x prime over dt prime squared, and that's equal to the force in F. So the force in this F frame and the force in this F prime frame. So we go on. We need to find the acceleration. So we need to find x using the chain derivative. Again, I'm not going to do that for you. I can't show you everything. We get this equation. And given that dx is dt equals vx, we can obtain the acceleration. And here's the acceleration. Now, but in order to attain this well-known SR formula, it is necessary to set Vx equal to V. Now, if you look up in here 7, Vx is equal to V. Why? Because this has to become V squared over C squared. But this spontaneously non-existent, no physical meaning Vx is being set to V. Again, this simplification has no physical sense. That's what he's saying. There's no reason for setting these two velocities equal. To confound the matter, the exponent is 2/3 in equation 8 and does not end up matching the 1/2, which is the square root. Of course, when you take something to the 1/2 power, it's the square root. In other words, even with this strange assumption that this spontaneous Vx, which is not physical in any way, that must equal V, because if you have two velocities, why would it be equal V? There's an infinite amount of ways it could be. It still doesn't match the desired Lorentz component. So this idea that special relativity will generate these Lorenz equations, that was one of the things that people in the beginning of special relativity said, see, this is what happens. It doesn't happen. Even more strange phenomenon in Einstein's derivation is the question of why he didn't set the velocities equal to each other back in equation 3. Why? Yeah, why are they not equal to 3? Oh, well, look at this. If it is, guess what happens? It's 0. Because the problem, if he did, the result would be strange indeed. Either 0 or this 2v. This emphasizes again the utter irrelevance of the two velocities being equal. In reality, there are an infinite number of choices for it, of course. There are. Why would they be the same? Now, he goes on to talk about AD, okay? I'm not going to spend a lot of time on, I'm not going to spend time on that today. We can talk about that if you're interested in to find out. So what happens? Carezani finds these things. He's at a time in the 1940s where this was still fresh in people's minds. Today, you know what they say? Oh, this is old stuff. Can't have, you know, this doesn't matter. And it doesn't matter how, it matters what you come up with in the end, or they wave their hands, or they don't even acknowledge this. That's what usually, it's just silence. But what's happening is when they're saying, when Carezani looked to see how special relativity would end up generating the Lorenz equations, and they don't, he found out that in fact, there are no frames. The idea that everything, imagine that everything has a frame. Every particle, every subatomic particle, and they're all traveling at different speeds, some at speed of light, some at slower, but what a mess this world would be in. He has the two postulates is Light travels the same speed as measured by everybody, no matter what their frame. And in any inertial frame, all physics is the same. Well, if all physics is the same in every inertial frame, then why does physics have to change? Why does my clock have to slow down? Why do I have my mass increase? And why does length contract? It's a mess. So again, this shows very clearly in a mathematical way, and this took a long time. Very brilliant, brilliant man. And I can't, like it says even in the beginning of this article, you have to go and do it yourself to show these things are true and that the mathematics works out this way. But what Carezani ended up finding was that, in fact, the universe has only one coordinate system. And then just because you're on a train and you turn a flashlight on and you're going past somebody on the ground, and then you follow all these weird equations that clock is slowing down, that this length is contracting and this mass is increasing. Oh yeah, they don't see mass increase in particle accelerators. Who told me that first was Carezani? I went and confirmed it, put it in my movie, confirmed it. Guy says it from the Stanford Linear Accelerator. Well, all this stuff happens because there are no frames. Mathematical systems help us calculate things. But the idea that there are frames and that there's these transformation between frames and that light has to be measured the same in those frames, you are setting yourself for disaster. So this proof shows that there is no way and no reason why these operations and these equations can work, because there's no physicality for Vx. There's no reason in this argument to set these two V's when equal, when they could be any speeds. If they're, it's ironic. If they're equal to 0, it means there is not another frame. It collapses. It blows your mind. How many ways do you have to see this? Carezani, thank you so much for showing this. And he developed a different set of equations, because when you get rid of them, then all of a sudden you have the idea for a body with no other external energy to move itself. It's got to be like a rocket. It's got to shoot stuff out and lose mass. A rocket. It's not that mass increases with movement. At the very fundamental, for something to move itself, it's got to get rid of some of its mass, energy, whatever you want to call it. And we can go through that if you guys are interested. It's quite amazing. So I hope going through this, again, go through this page. If you don't know differential equations, at least go through and try to figure that out. If you want to do the math, figure that out yourself. But Carezani, thank you so much. I hope you've enjoyed this. I hope you understand now that these things have been discovered. This in the 1940s. It's a fact, it's a flaw, and it must be thrown out. Period. And there's lots and lots and lots and lots. It's thousands and thousands and thousands of scientists around the world who know this is wrong. They may not know this particular reason, but there are many, many papers. And we are putting on our website links, and we are creating our new homepage for the CMPS for critical thinkers that's going to show you lots of examples. And I'm going to go through some other examples that are not so intense. But in my opinion, this may be, in fact, the best argument mathematically and physical using their own math to do it. Dr. Carezani, one of the most brilliant minds of the 20th century. Thank you so much for what you've done. And it's a shame these people aren't being recognized, but we certainly recognize them here. And remember what I say. Don't take my word for it. It's here. I may have bobbled even something I said wrong because, when you do these things live on the cuff, go through it yourself. Read it for yourself. Take a look at it for yourself. Don't know calculus? Learn the calculus to show this. But don't come back and tell me that it doesn't matter because it's a process in the middle and it doesn't happen. Yes. When you have math, everything in those equations must have some meaning. And if it doesn't, you have to put it and say it's magical, something like that. But in this case, Carezani is absolutely right. Only one frame in the universe, and the most we can do is move the origin and make our calculations from there. Remember what I say, don't take anything on faith. What people say on faith. Stay critical, stay thinking. I'm Dave D. Hilster. I'm your science therapist. There you go, a real live example. Gonna shoot me down now? Go at it. Ciao for now.